Okay, you're welcome back. This is Boyles Law. Boyles Law, in gas law, we've discussed a lot about gas laws, and we are treating Boyles Law now. So, first of all, what we'll have to notice in Boyles Law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature remains constant. Boyles Law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature remains constant. Just like I explained before, in gas laws, you have to keep one thing constant to make others move so that you can calculate others. You have to keep one thing constant so that you can calculate others. Mathematically, we have that V is inversely proportional to 1 over P. This is the sign for inversely proportional. This is the sign how we write inversely proportional, and this is also equals to, if you want to put equal to here, you are going to put a constant, that is K. That is K. In this equation, K is representing our temperature. So PV is equals to constant. That when you cross multiply, V times P equals to K. That is PV is equals to constant. So if you make it in two ways, so PV is equals to P1V1 is equals to P2V2. That's if we're considering two gases. So in this place, we have that pressure can change, volume can change, but our temperature is what? Constant. Our temperature is constant. We are discussing Boyles Law. Please don't forget, we are discussing Boyles Law. Now, let me teach you. So if you watch here, you're going to see that P1V1 is equals to constant. P2V2 is equals to constant. That is gotten from here. PV is equals to constant. So P1V1 is equals to what? Constant. P2V2 is equals to what? Constant. So P1 is what? The initial pressure. V1 is equals to the initial volume. Then P2 is equals to the final pressure. V2 is equals to the final volume. So P1 V1 is equals to constant. P1, so which is equals to constant is equals to what? Constant. From this one, P1 V1 is equals to constant. P2 V2 is equals to constant. And from here, we have that PV is equals to constant, and constant being equal to constant, we have that P1 V1 is equals to what? P2 V2. So hope you have understood the relationship we did here. Let us go into the questions proper. Now we have that a fixed mass of a gas occupies a volume of 20 cm cube at a pressure of 700 millimeter mercury. Assuming that the temperature remains constant, what will be the volume of the gas? They said a fixed mass of gas occupies a volume of 20 cm cube at a pressure of 700 millimeter of mercury. Assuming that the temperature remains constant, what will be the volume of the gas at 750 millimeter of mercury? This question was asked by WAEC. So let us go forward. We have that P1V1 is equals to P2V2. That is our formula. P1V1 is equals to P2V2. That is what? Our formula. So we come there, P1V1 is equals to P2V2. So now for the solution, we have that P1 is equals to 700 millimeter mercury. P2 is equals to 750 millimeter mercury. V1 is equals to 20 cm cube, and then V2 is equals to dash. Nobody knows V2 yet. Okay, so P1 V1 is equals to V2. So V2 is equals to P1 V1 all over P2, which is equals to 700 times 20. 700 is equals to P1, 20 is equals to V1 all over 750, which is equals to 18.66 cm cube, which is equals to what? 18.66 cm cube. You should do this with your calculator and then you'll find the answer. We've calculated the first questions in Boyles Law, and this is how we do it. P1 V1. Remember that the temperature is constant, so the temperature is out of the question. We've calculated it, and this is how we do it.